So in this video, I'm going to explain the unit circle, where it comes from, and tricks on how to memorize it. Okay, so the x-axis and the y-axis on the unit circle. A unit circle, like we have discussed in the past, it is a unit of one radius. It's a radius of. So the x-axis and the y-axis in the unit circle is a circle that has a radius of 1. That is why it's called the unit circle, is because it has a radius of 1 unit. So therefore, you can go ahead and know what the coordinate points are going to be at each axis. So this is also going to be 1, 0, because literally you went over 1 and you didn't go up or down. The y is going to be 0, 1 because you only went up. This route, you went to the left 1 but didn't go up or down. And then obviously down, you didn't go left or right, but you went down 1. So that is the axis for the unit circle, are these coordinate points. Now, we have talked about with trig functions at any angle that this represents the coordinate point. R basically is the hypotenuse. And to get to this terminal side, you had to go over x, which in this case is to the left, and then you went up y. So if we were to say that this is theta, the sine, remember, SOHCAHTOA. Sine is y over the hypotenuse, which is r. Cosine is x over the hypotenuse, or the adjacent over hypotenuse. Tangent is opposite over adjacent. And then cosecant, secant, and cotangent are their reciprocals. But here's what's really cool about unit circle. We know that r is 1. So therefore, anywhere you see r, it is the number 1. So therefore, number 1. So therefore, I can actually say that sine of theta is actually your y value. Cosine of theta is your x value, and then tangent is already said y over x. And then cosecant means it's going to be 1 over y, secant is going to be 1 over x, and then cotangent is going to be x over y. So we now know that this coordinate point right here can actually be written as cosine of the theta and sine of the theta, because we know that x represents cosine of the angle and y represents sine of the angle. So we can actually rewrite coordinate points. So the x and y axis, again, we discussed was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now we're going to include the degrees and the radians. So we talked about that when you start, the initial side is always the positive x, and it starts at 0 degrees. And then we know that when you go one full circle around, you have reached 360 degrees. So halfway is going to be 180 degrees, 3/4 of the way is 270 degrees, and 1/4 of the way is 90 degrees. Then we also discussed radians. We started at 0, and we talked about how halfway around the circle, 180 degrees is the same thing as pi, because there's a conversion factor of pi over 180. So 180 degrees is the same thing as pi, which means all the way back around is going to be 2 pi. And then if this is pi, this is half of a pi, and this is 3/2 of a pi. So this would be the next thing for the x and y axis that you need to learn. 1, the coordinate points, which are these. Then you need to learn the degree and the radian at that point. Now we're going to do the 45 degrees on the unit circle. So every 45 degrees, it happens at 45 degrees, then 90, and then 135 degrees, 180, 25 degrees. So in the past, we talked about special right triangles. And anytime you have a 45 degree triangle, how do I know these are 45 degrees? Think about reference angles. If you were to draw a triangle, this would be its reference angle. And so that's why these are 45 degree, this is a 45 degree, this is a 45 degree, this is a 45 degree. And we talked about how the sine and cosine are both square roots of 2 over 2. So every 45 degree you're going to have square roots of 2 over 2. It's just going to change the negative based on where you are on the coordinate plane. 30 degrees and 60 degrees, we've also previously talked about of how you get what you get on there. At 30 degrees, you're going to have this coordinate point, and at 60 degrees, you will have this coordinate point. And again, pause the video if you need to look at these longer as we are working through these on the unit circle. So therefore, this is where it gets weird. If you notice, the 45 degrees are not on there. But the 30 degrees, so for example, 30 degrees right here, all right, would be the triangle. This is also 30 degrees if you think reference angle, because that's 30 degrees. 30 degrees here is a reference angle, and 30 degrees here is a reference angle. Those are all 30-degree reference angles. And so that's why, if you notice, those all have the same coordinates, except the negatives change based on where you are on the coordinate plane. At 60 degrees, the opposite happens. So at 60 degrees, this would be a 60 degree right here. If that's 60 degrees, this is 60 degrees based off of reference, which means this would be 60 degrees, which means this would be 60 degrees. And that's why all of those coordinate points also have the same coordinate points, except the negatives are going to be different. So let's look at just one quadrant. At 30 degrees, you have the coordinate point square root of 3 over 2, 1/2. At 45 degrees, which is this one, you have square root of 2 over 2, square root of 2 over 2. And then at 60 degrees, which is this fine purple, at 60 degrees, you're going to have the opposite of the 30 degrees. If you notice, they are opposite signs. If you can memorize just one quadrant, all the other quadrants actually reflect the first quadrant. So here, if this is 90 degrees, this is 120 degrees, 135, and 150, because a reference angle, 60-degree reference angle, 45-degree reference angle, 30-degree reference angle. That is why those coordinate points are the exact same coordinate points as quadrant 1, except the x's are negative. Why are the x's negative? Because you had to go left on the coordinate plane before you moved up. And to discuss all of it together, you will be memorizing the unit circle of all the degrees, 30, 45, 60, 120, 150, 240, blah, blah, blah. You will memorize all of the radians. And then you will also memorize all of the coordinate points. And that is the unit circle.